welcome to first Fake Intelligence Summit. I'm Harri Ketamo, and on behalf of Program Committee, I welcome you here. When we decided to set up a Fake Intelligence conference, we felt that there is a need for a conference where we can talk on the topic without the bubbles of marketing and stuff like that. Because we know that even though AI is a great tool, there are limitations we should discuss about. It don't solve all the problems, so I can't just go and say, hey, I want one AI and it fixes my problems. So that's why we need critical discussion. What it is about, what are the limitations, what kind of bubbles we recognize nowadays, and, well, what are the topics we really need to discuss. And we put out a call for papers, and we get 8 excellent papers. But unfortunately, quite many of those weren't able to come here and ask for possibility for online. And that's why we decided that this first Fake Intelligence will be online, and we will have this smaller on-site gathering around the topic and the presentations. And today, here on site, I'm giving a short introduction on the conference topic, and we will have a keynote from Professor Subramanian from Dartmouth. And then we will check through 3 presentations, because we said that we will have Critical Thinking Awards and Best Paper Awards, so we will check Best Paper and 2 Critical Thinking Award presentations. And after that, we have another keynote from Taneli Tikka, our local fund director, the Finnish Fund for AI and Rising Technologies. He's not here, but it's a video keynote as well. But the idea of this gathering is to build networks. So we try to spend a lot of time on discussions and having discussions what we can do together, what kind of cooperation we need, and what we can do together, because that's why we are here. Not only watching videos, but more discussing with each other. So once again, welcome here, and let's go a bit deeper to topic. In a couple of minutes, illusion of intelligence. In games business, the idea is to create illusion of intelligence, and they have been good on that. In storytelling, the illusion of intelligence has been always there. We have some 3,000 years of expectations on intelligent machines. Like in Greek mythology, there were Thaloses, the machines that were forged by the forgery god, and they were protecting ancient Greeks from pirates and other ugly stuff. Vikings as well. In China there were terracotta armies. In Finnish ancient mythology there were a forger as semi-god who forged a bride from silver and gold. Well, the bride was a bit mean, so the silver and gold bride was left. But anyway, there is thousands of stories about intelligent machines. But what is this illusion of intelligence, and why I use word illusion? We have very different levels of intelligence. For example, flock of birds. Their behavior in individual level, individual bird, might seem random, or at least non-systematic. But if you follow the flock of birds, there is intelligent how the flock of bird moves, how it behaves. So the intelligent in bird is not in one bird only, but it's in flock and how the flock moves. And that's very interesting, because very simple behaviors can construct highly intelligent behaviors when they are summarized together. And that's why in nature we have very interesting topics. We should discuss more to understand the extremes of intelligence. There is no one intelligence, it's a huge extreme. And the same goes for games. I think every one of you knows Pac-Man. And the 4 ghosts creates an illusion of intelligent behavior, at least entertaining behavior. But a single ghost is very simple as an AI point of view. One is following you, one is avoiding you, one is always turning right, and one does attacks and then backs out. And well, those four super simple behaviors altogether creates an illusion of at least entertaining, but I would claim intelligent teamwork, intelligent behavior between the ghosts. But it doesn't exist. So this is part of storytelling. And in fact that goes on any game, Age of Empires, any later. It's based on very simple, independent behaviors, but then altogether creates an understanding of intelligent behavior. So it's cumulative behavior, simple behaviors in cumulative way for more complex behaviors. They are scripts. Well, the intelligence in chess. Chess has won man or human long time, and the chess machines are based on modern chess machines, rules and data. So how people play, but also rules. The big difference is when going for Go. The victorious Go machine don't know the rules of the Go. It has just algorithm that has been taught by what is the starting stage, ending stage, so what has moved, and what was the outcome. Was it neutral, victorious, loss, positive, negative? And then billions of these kinds of rows in training. And even though without understanding the rules of the Go, such algorithm can build a model that from this position or this stage in the table, what is my shortest path for victorious game? No need to understand the rules. And that is also intelligent. Even though as an algorithm, well, maybe I simplified it a lot, but as an algorithm, this is really simple. But from behavior point of view, beats the most talented Go player in the world. So that's why intelligence is not the intelligence like Terminator. All the intelligence we have nowadays are more storytelling, like Go machine. It's really good in Go, unbeatable, but the Go machine can cure cancer. And vice versa, the machine that can detect cancer can't play Go. Even though they might have exactly the similar basic features in the algorithm side, so deep learning mainly. But they can't do the other work. And that's the illusion of intelligence. And now finally going back to learning. I think all of you have seen Matrix, the movie, where everyone learns in a way that they plug in the brains and just feed the knowledge. And you can fly a helicopter in seconds. And we have dreamed that we can do that also for people. So learning would be easy. Learning is just transferring data into brains. But, sorry, that doesn't happen. More than 100 years ago, Edward Thorndike designs a machine that was meant for adaptive learning. The idea is that the machine, using punch-hole cards, no digital computers at that time, the machine asks questions, and based on your answers, the machine suggests you further readings and next question. And in area of adaptive learning, nothing has changed in 100 years. We have more data, more computing power, but the basic ideas are pretty much the same. But where's the illusion, or where's the bubble? It's in suggestions. In Amazon or any modern web store, there is suggestions that, okay, customer who bought this product has also bought these products. Customer who recommended this product has recommended also these products. And today, way too many edtech providers turns this mechanism to learning products, saying that we are using people-based suggestions like web stores. And because web stores are successful, this is also good for learning. But what happens? The first customer buys an idea of flat Earth. And by the way, such society exists nowadays, flat Earth society. Flat Earth society bought a learning. And because Flat Earth Society guy thinks that Flat Earth is okay, also Earth-centric world is okay. So our learning machine suggests, because Flat Earth is true, also Earth-centric space is true. And where's learning? So such machines that based on suggestions are so easy to cheat, so easy for building a bubble around them, that we should as a society say that adaptive learning is not that simple. It's not marketing. Because in marketing, you are just, no matter what you do, you are maximizing your revenue. In learning, you should be able to be critical, be able to see why something is suggested and what is the relation to the big picture. And to avoid to get picture, we can't do that, we can do it. But it's way more difficult than just saying that because my friend thought that Earth is flat, and he has suggested also that the Earth is center of the universe, we should only learn that. No. We have had conceptual structures about any topics for more than 40 years. We can measure individual progress on topic and build understanding if I know something, what I should learn next. If I have difficulties in something, what I should revise. And that's based on not only understanding the knowledge domain, but also understanding in details what user knows. Such machines in the web stores don't have knowledge domain nor understanding about user. They have just data about what others been doing. And that's one bubble in learning side I want to discuss, because in reality the mind maps about suggestions are not because I suggest something, others should do so. One micro square meter on a real knowledge graph. So, thank you. And well, once again, welcome. Next we will take our keynote from Professor Subrahmanyanam. Welcome.
Thanks.